Hello and welcome to ACT-U8. In this video, I'm going to show you how you can control and actuate DC-112 in real time using ACT-U8 Studio running on your Windows PC. Let's get started. So to start with, you can see that I have my ACT-U8 DC-112 down here connected via USB to my Windows PC here. This PC is running ACT-U8 Studio and I'll show you that in just a minute. So the controller down here is driving one of the linear actuators in my arm here. Happens to be this linear actuator right here. Here's what that actuator looks like. It's an Actuonics P16 series. These are great linear actuators and they pair really nicely with the ACT-U8 DC-112. So this robot arm here was built from Actobotics components from the great folks at Servo City. And we're going to show you how that moves in just a minute. So if you go over to the ACT-U8 Studio, you'll see that the controller is turned on. It's right here. When you click on the name of the controller, it's going to show you some information about it, including the firmware version, the COM port it's connected to. We're going to go down to drive control. Drive control has two parts. First is a graph of the real-time status. You can see the legend down here. It's going to show you the trigger input. It's going to show you the current torque being generated by the motor, the desired path of the motor, as well as the current position of the motor and the drive control to the motor. On the right side is the control section. There is the drive on and off that activates the motor or deactivates the motor. And then there's the control on or off, which turns on or off manual control mode. So we're going to switch this to on. And you'll see that this little summary here switched from an S to an M. And then I'll explain this part down here. The left is a range slider. You can set the minimum extension and the maximum extension. So I'll move these in a little bit just to demonstrate. So maybe like that. And then the right slider sets the percentage of the orange range here, the active range. So I'm at 50%, which translates to a position of 0.45. If I move the maximum down a little bit, you'll see that that 50% spot changes. Now I'm down to a 0.4 as the 50% point. So we'll go ahead and turn drive on. You'll see the robot arm start to move and you'll see the graph start to update. And there you go. So the robot arm moved up to 50%. We'll take it down a little bit. And you can see when I go to 0%, it goes down to the minimum position of 0.2. And when I go up, it goes to the maximum position of 0.6. Okay, you can see that it responds in real time to me moving the slider. And you can see that it's pretty smooth. So when I move this slider around, the command point of this slider is not going directly to the PID. It's going to a trajectory computer, essentially building a path of trajectories to say, what is the smoothest way to get me from my current position and velocity to the desired position and velocity? And it could include a sequence of trajectories that might include stopping, reversing direction, speeding up or slowing down to try and match. And so you can see if I move it around quickly, it's not going to jerk around. It's going to come up with the fastest way it can respond. And again, the trajectory path that it develops is designed not to exceed the maximum velocity or acceleration that you've set for that linear actuator. Okay, when you're done moving it around, you can turn the drive off and the motor will stop running. The graph will stop updating. All right, so in this video, I've showed you how you can use an ACT-U8 DC-112 connected to your Windows PC, and you can control that device in real time using ACT-U8 Studio. Thank you very much for joining me.